Welcome back my dear friends. A very good morning, good afternoon, good evening to all of you. And as you know, this is the data analysis and decision making one course under NPTEL MOOC, and this total course is for 12 weeks, which is total number of hours is 30, and which would be total 60 lectures. Each week we have 5 lectures, each being for half an hour, and as you know, this is the 45th lecture. That means we are in the last class for the 9th week, and as usual there would be assignments after the each week. So, you obviously will get the 9th week assignments also. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing about utility theory, concept of non-satiation, concept of risk aversion, risk loving, risk neutral. Then we discussed that giving the example of a fair gamble, where there is a coin which is unbiased, probabilities are half and half. There is another coin, in case 2 there is a probability is 1 bias coin, and the investments which you are doing per they are only of 1 unit, or decisions you are taking is of for 1 unit, and the outcomes in the unbiased case, which is the fair gamble, is probability is half and half, the outcomes of 2 and 0, and for the case when it is a biased one, there is only one outcome, the outcome is 1. So, the expected values between both the cases is 1 and 1. Now, based on that, we said that if intrinsically the person is willing to take the gamble, then he is willing to, he is a risk seeker. The person is indifferent between the gamble and the certainty, certain or the deterministic case is basically indifferent person, and the person who wants to take the certain event where the biased coin is there, in that case the person is basically trying to avoid the risk. Now, we also said two other important points is non-satiation, more I give more you want, which means the first derivative would always be is greater than 0, but this property of whether the person wants to take the risk, wants to basically be indifferent and wants to run away from the risk would basically depend on the second derivative. So, the second derivative being greater than 0, being equal to 0 and being less than 0 would basically classify the human being as willing to love the risk, take the risk seeker. The second case when it is indifferent would be the case when the second derivative is 0. And the third and the last case would be if the person wants to avoid the risk, is a risk hater, in that case the second derivative would be less than 0. And how it is possible, I will show you the graphs accordingly. So, consider the utility curves. So, along the x axis we plot W, which is the wealth, any unit, and along the y axis we plot the u of W, which is the utility function. So, we have 3 graphs, the green one, the blue one and the red one. What are they? They would become very apparent, and there is no such apparent reason why I have drawn from a certain value on the y axis. This is just to give you a notion that they can start at any point. It could have been started at origin also. Now, based on that we want to analyze. So, watch the slope of the graphs. I will use the different colors corresponding to the graphs. So, I will use the green one, highlighter. So, it is increasing, but increasing at a slower rate. Now, consider the blue one. Hopefully, I am able to draw it. This is the one which is increasing. So, basically the green one is for increasing at a decreasing rate, blue one is increasing at a constant rate, red one is increasing at an increasing rate. So, obviously, it would be very apparent here for all these graphs, the the red one, and you draw the red one first, the blue one and the green one. On this case, now come to the second derivative in the red one, the blue one and the green one. Oh, I am not drawing W, sorry, it will be easier. So, this will become very apparent in the discussion which we have. So, the marginal utility functions looks like a concave. When it is concave, it is a risk averse. So, I am basically running out the risk. Marginal utility functions, which is the based on the first derivative. So, these were the first derivative which we drew, the actual function, and then based on that we find out the derivative. The marginal utility function looks neither concave nor convex, is a risk neutral person, and the marginal utility function looks like a convex function, would basically be a risk seeker. So, how we drew is like this. So, this is the same thing, sorry, there is a repetition. Okay, it is concave, not the repetition in the sense that I have basically dealt with two topics differently. So, the marginal rate is increasing and an increasing rate, decreasing rate would be the risk averse person. Marginal utility rate would be increasing at a constant rate, is a risk neutral person, and marginal utility rate is increasing at a increasing rate, is a risk seeker. So, increasing, decreasing, risk averse, increasing, constant is risk neutral, and increasing is the risk seeker. So, let us see the graphs. So, this is the green one, if you remember. So, this is the risk avoider or risk hater. So, if you draw the marginal rate, so this is theta 1, again I draw, this is theta 2, in this case theta 1 is greater than theta 2, because the tan of this angle is to be considered. Then I come to the risk neutral person. So, the tan in this case is same, so it does not matter. Now, come to the risk lover. This is theta 1, theta 2. So, this is a risk seeker person. So, concave, convex, and neither concave, neither convex. Now, few other continuing with the discussion. So, risk averse person would reject a fair gamble. If you remember, I had discussed that, considering there is, so there is a gamble, and in this case there is a certainty value. So, you really will reject the gamble, you are going for the sure event, because you think even if the probabilities are same, in the sense it is half and half, you will think that you will be getting the downward trend outcome, hence you are avoiding risk, you are a risk aversion person. Risk neutral person will be indifferent to the fair gamble, that means whether you get the gamble, do not get the gamble, you will basically be equally disposed in both the sense. And risk seeking person would be the one who will be looking at the upward trend on the gamble and select the fair gamble as the choice. So, again as I mentioned, it will be the let me check the color, so it will be easy for you to understand. So, it is green one was basically the risk avoider. So, we are right. So, this is the risk avoider person, this is the risk neutral person because second derivative is 0, and this is the risk seeking person because the second derivative is greater than 0. Now, we will discuss two important properties from the risk perspective. One is absolute risk aversion property and one is the relative risk aversion property. So, absolute risk aversion property, what are the things, I will come to that later. So, in the absolute risk aversion property of utility, whereby by absolute risk aversion we technically mean that we want to find out the negative of the ratio of the second differential to the first differential. So, now the first differential is obvious, which is in the numerator is always, I am not marking it, is always greater than 0. So, your property of absolute risk aversion would depend on the derivative of the second property, whether it is positive, 0 or negative, and that would basically dictate that what would be the absolute risk aversion property and the derivative of the same, which is important for us to understand. So, what we need to find out is basically first find out the absolute risk aversion property and then use the ratio, so the derivative of the absolute risk aversion property, based on which you will basically be able to club a decision maker as a person who wants to take a risk, wants to basically be indifferent to risk and wants to basically avoid the risk. And obviously, that would come from the second derivative, the first derivative would always be greater than 0. So, obviously, the second derivative will dictate that what is the A and A prime property. Continuing absolute risk aversion, for the three different types of persons, you will basically have a decreasing absolute risk aversion property would mean that the person has in the absolute sense his or her level of risk is absolutely decreasing. Constant absolute risk aversion property would be mean that the first derivative of A, which is A prime, would be 0, and increasing absolute risk aversion property would be the case where the A prime value is basically greater than 0, and then you will basically come to the. So, in all these cases, what would basically be dictating is the U double prime, which is the derivative of the marginal rates. And if you remember the graphs, this is for the constant one and this is the increasing one. So, you are trying to basically measure W and measure U of W in the x and y direction respectively. Now, in the implication from the qualitative point of view, how would you state it? So, decreasing absolute risk aversion property would mean that as wealth increases, the amount held in risky assets increases. So, this is decreasing. So, if you are decreasing, so obviously it would mean that your A prime is less than 0, and as wealth increases, the amount of held in risky asset increases. That means, you are trying to basically be more and more towards risk, run towards risk. Constant absolute risk aversion property obviously would mean that A prime is 0, which means that as wealth increases, the amount held in risky asset remains the same in the absolute sense. And increasing absolute risk aversion property would mean that A prime is greater than 0, which means that as wealth increases, the amount of so called wealth held in risk asset decreases. So, we will come to this in more details. Now, we will consider the fourth properties from relative risk aversion property, which means that is the property of the utility function, whereby the relative risk aversion would mean by minus of W W multiplied by the concept of A, which means that if you are multiplying A with W, then obviously the property of A or property of R would be in the way, because W would be related in the sense, very simple sense way, because u prime is always positive, and what is dictating the sign of A prime whether greater than 0, less than 0, equal to 0 would only depend on u double prime, and obviously the minus sign is there for both R and A, that is immaterial. But also remember W is positive because that is the way wealth. So, any properties coming from A prime and A would also be reflected in R and R prime. So, because the concept of derivative when you are taking, W would not have an effect on the derivative sense because it is positive. So, for these three any person, as you know, we define him or her as risk loving, risk neutral and risk hater. So, from the point of view, these three different types of persons would be clubbed as decreasing relative risk aversion property, constant relative risk aversion property and increasing relative risk aversion property. So, in that case you will have basically R prime as less than 0 for decreasing relative risk aversion property, constant relative risk aversion property would means R prime is equal to 0, and increasing relative risk aversion property would be the case when R prime is greater than 0. Based on that we can basically find it out accordingly. Now, when we basically go in trying to basically understand in the qualitative sense, the conditions would be as it is the same thing. The conditions on left column, the middle column is the definition, and basically the properties would be discussed in the numerical way. How you analyze would be the last column. So, decreasing relative risk aversion property would basically mean as the wealth increases, the percentage held in risky asset would increase, which means that R prime would be less than 0. For the constant relative risk aversion property would be as wealth increases, the percentage held in risk assets remain the same, and obviously in that case R prime would be equal to 0 because constant is constant value. I am just giving the definitions, I am going to come to the solutions problems later on, please have patience. And increasing relative risk aversion property would mean that as wealth increases, the percentage held in risky assets decreases, which means R prime would be greater than 0, and we will utilize these properties accordingly. Now, here is where we utilize. So, we will consider 4 different examples of utility function, very simple one is the quadratic one is the logarithmic one, third is the exponential one, and the fourth one is the power utility function. So, in the quadratic utility function, what we have is basically of a quadratic form. So, it will basically be ax square plus bx plus c in general, x being w. So, but the equation form will be w minus b of w square or w plus b of w square, where that value of b can be positive or negative depending on how you want to basically express it. So, b is a positive quantity in this case. So, obviously, it would mean that minus b of b w square, as b is positive, would be minus, because the minus sign would dictate. In the logarithmic case, it is the Neperian log. So, u of w is ln of w, and in the exponential case, you will basically have the exponential function, which is minus e to the power minus a w, where the a is basically a positive quantity, and in the power sense it will be c, which is a constant, into w to the power c. I will come to these definitions more, but I am just stating them in the mathematical format. So, first let us concentrate on the quadratic, and then obviously the properties of relative risk aversion, then R prime, absolute risk aversion, A prime, the properties, what the derivative means, first derivative, second derivative of u, all these things would now become clear for all these 4 different utility functions, and we will solve them very simply. So, first we are going to consider the quadratic utility function. So, the quadratic utility function is given by w minus into b into w square. So, let us basically make us blank slides and solve it. So, we have made the 2 blank slides. Now, I will basically go through the derivation. So, first let me write down the utility function, quadratic one. So, I will only write u, not the w one, is equal to w minus b w square. So, first
u prime is equal to 1 minus 2 bw, u double prime is equal to minus 2b. So, it becomes 1 minus 2 bw and this becomes okay. Now, I need to find out a is equal to minus u double prime by u equal to minus of, I will write it is as minus 2b and u prime is 1 minus 2 bw. So, this become plus. Now, basically I will solve it for a prime. So, once you solve it from a prime, so we will use the function as of f as u by v. So, v into u prime minus the actual calculations u into v prime by v square. So, once you solve it, the actual values which you will get is a prime is this. So, let us concentrate. So, the numerator is always positive because w b square and the denominator is always positive because the square term. So, whether b is positive or negative is not going to matter. So, a prime would basically be positive, which means it has an increasing absolute dispersion property. Now, when we find out r, in the r case, the relative one, r means relative risk aversion, basically that a value multiplied by w is always positive. So, finding an r prime would give me the value which is now in the numerator v of 2b divided by again a square term would not matter. So, the b value if it is positive, we will have basically positive r prime, hence again it is increasing relative risk aversion property. Now, this is what I do in order to basically make things understand, and anybody can solve it in Excel sheet. So, what we have is basically we write down the values of w on the first column, the second column we have basically the values of u for the utility function, and the corresponding third and fourth column I have basically not given here, but let me concentrate on how we can make it. So, obviously, this is this is u. So, once you have, you will basically have u prime, which is not there. So, u prime would be technically you know the prime value would be u with respect to w2 minus u with respect to w1, the whole thing divided by w2 minus w1. So, this would be 5.25 minus 3 divided by 3 minus 2, that will give you the first derivative for the first case. The next would be 8 minus 5.25 divided by 4 minus 3, that would be the second value of the first derivative. Then it will 11.25 minus 8 divided by 5 minus 4, which is the third value of the first derivative. So, based on that you can find out the u prime. Again I want to basically find out the u double prime, it will basically be the u prime for w2 minus u prime for w1 divided by w2 minus w1. Find out these values and you can proceed accordingly. Again the same thing. Then I use the formulas for a is minus u double prime by u prime, put those values, find out a, then find out the derivative of a, which is a prime, again the same thing. The a value of w2 minus a value of w1 divided by w2 minus w1 will give you the a prime value. Similarly, I write down the r and the r prime values. So, you have the first column w, second column u, third and fourth column are not given here, which is u and u prime. Then the third column, or technically the fifth column, which is there in front of you where I am hovering my electronic pen. So, this is a prime a prime r prime, the values would be given and you can plot them. So, let us plot it in Excel, even though it is very small, but I am sure you can do it in order to make yourself very clear. So, the pink color is basically u function. So, I do not have this. So, I use the yellow one for the time. I don't have the luxury to use the yellow one. I will use the orange one. Do I have? Yes, orange one. I will highlight it. So, this is basically u is a quadratic equation. The yellow one where it will be here would basically give you a, the pink one, and the light greenish blue would be the a prime, the violet will be r, and the brown would be r prime. So, you can basically plot them from the data which you have, and basically can have an understanding how the graphs for the quadratic utility function look like and how a and a prime are calculated and how r and r prime are calculated. Now, we go to the logarithmic utility function. So, in logarithmic utility function is ln of w. So, you want to find out the differentiation of that. Ln of w differentiation is 1 by w, and double differentiation would be minus 1 by w square. You put these values, based on that you can calculate a, and then you can calculate a prime. Similarly, you can calculate r and r prime. The values are given as it is. A prime is given by minus 1 by w square and r prime is given by 0. Hence, from this you can understand it will have a utility function for the people would be decreasing absolute risk aversion property, because it is minus 1 by w square is positive. So, it is negative, and it is 0, that obviously it would mean is a constant relative risk aversion property. Then again I do the same thing, I plot the values of w in the first column, u of w in the second column, third and fourth columns are I have not drawn it. You can simply draw it using Excel, where you are plotting u and u prime. U is basically ln w, you can plot u prime and u double prime, plot it, and based on that you can get a prime, r prime, and you can see the values of r prime which we just calculated using mathematics is very simply matching if you do the calculation. So, it is 0, and in that case the a values, which is more important also, is also negative. You can plot them, and once you plot these values, again you will have the pink one for u, then the yellow one for a, the a prime, r and r prime values are given respectively, as I am just mentioning the colors. If you plot it, it will be much better. Take the trust me and follow the instructions, just utilize the values which are given for the quadratic one and the logarithmic one. I will repeat them for the other utility functions also, and you will plot them, you will get the equations as it is given. So, it will be much easier for you to understand it. So, the greenish blue, the violet and the brown are respectively for the a prime, r and r prime. So, with this I will end the 45th lecture, which is the end of the 9th week, and I will continue discussing more about the utility functions in the beginning of the 10th week, and then basically go into the applications in the regression and the other fields. Thank you very much, and have a nice day.